That's the title of the YouTube video. Examples to help with homework 3. So you can easily find it. You do, since all of you took linear algebra, it doesn't mean that you 100% understood it. We're just going to revisit some of those things in linear algebra, and that's what your homework is, but using the definitions. So I told you that in graduate school, we teach linear algebra with transformations first. I don't think we even do matrices. We just teach it with transformations. Transformations are just functions. You hit linear transformations, I think, towards the middle of the semester, and they talk about it, they mention it, but they go back to matrices again. And that's because matrices are a tool to really work with those functions, but they are indeed functions. So if I take, for example, T going from R2 to R2 using our language, which is the right way, the math way, the X and the Y, in my case, are going to be R2 and R2. And T is a function that takes R2 elements and maps them to R2 elements. The two planets are R2 and R2. And I'm going to give you a function. So I'm going to input in x1 and x2. And then I'm going to output out the vector x2 comma x1. So I can tell you what this does. If I plug in, I can plug in a few things. Let's plug in a few things. T of -1, 1 is equal to, it takes the x2 element and puts it first, and takes the x1 element and puts it last. So I can actually plug and chug just the way I did when I was in grade school and first learning how to graph functions. The only problem is you can't graph this. Kind of. You can have two R2s up, and then your teacher did that in linear algebra. Whether you might have forgot it, but they'll take one vector and one R2 and then show you what the transformation did to that vector on the other side. Or they'll have one graph they're good at drawing and then show you with dotted lines what it did to this vector. It moved it here, or it did this, or it shrunk it, or it expanded it. Every time you use your smartphone, you're using this stuff. When you go like this on your smartphone, that's a scalar expansion of in R2 of a vector. You're taking a vector and expanding it. When you rotate it, the whole thing rotates. It's using a linear transformation. So this stuff is actually useful too. I was kind of surprised physics majors don't have to take it. Like, how do you not take that? Good. Yeah, I heard that not everybody has to take it. It's like, that's like breaking your leg and asking you to run a marathon. All right, so I'm going to show you that this particular function's one-to-one. That's what I'm supposed to show. That's the definition of one-to-one. So I go right back to my first principles and the definition. Still see writers. Sorry. So I'm going to set up two vectors because these are vectors. Isaac, tell me when. Right. Isaac, also tell me to stop if I'm going too fast because I don't want it to not be in your notes. Okay. So I have to set these things up. I'm using different notation because it's just we do. You can set up your vector like this, AKA it's the same thing as this. Same thing as this. Yeah, I skipped over like the proof stuff. I want to make sure that you have this for your homework. All right, so I'm going to set t of x equal to t of y. And I'm pretty much done. Setting components equal, I get that. So the two vectors are the same. What book did you guys use for linear algebra? Do you remember? I'm being recorded. Oh, I'll keep my language clean. That's not a good book to learn from.
Which one did he say?
People love Strang because it's got like a pure math bent to it, but it's not a good book to learn from because it assumes you kind of know something before you actually use it. So there's another book that's used often. It's written by a guy named David Ley, and he'll have these definitions and he'll keep building on them. That was yeah. That was a good one. So if you actually go back and look at that book, you'll see that he's written in there, like this is 1-to-1, and he brings it back to what it means, but then you'll get ways to use matrices to understand this. All right, one more. This is how you show something's onto. Say I have an arbitrary y in R2. So that's given. I got my y. I've set it down. I need to find an x belonging to R2 such that. Oh, are you guys familiar with this notation R2? That just means vectors with two components. Should have got that in linear algebra. The R2, the reals with the two. So I need to construct the X task oriented. So I kind of think like, hey, that's work for me. I'm going to have to construct this guy, but I'm going to set my X up. Y is given to me already. I'm going to set it up to be Y2 as the first component and Y1 as the second component. That's my X. If I plug that into T, well, T takes the second component and makes it the first, and it takes the first component and makes it the second. So this is what T does to this Y, this thing that I put here. It does this, and that's my Y. So it's like a formula. You give me an X. 1, 2. I mean, you give me the Y. 1, 2. I will give you the X. 2, 1. 2, 1 gets mapped to 1, 2. You give me any Y, I can give you the X because I did it for variables, right? So this is a formula for how to find that X.
The X in the function.
Yes.
So it's like go on where you want to go.
Right. Right. And you think of things where it doesn't work. I can easily give you, I think I do give you ones in the homework where it doesn't work. And I ask you like, find me something where it doesn't work. So you can take a Y and it doesn't have an X that it came from. So if 1, 2 is Y, T of 2, 1 equals 1, 2. So there's my x. So this is just a formula now to find the x for any y, for any arbitrary y. So I'm gonna let you catch up with everything, and then I'll make a video for the second part of your homework. I have another example, so you can look at that when you. So this is one where it worked out nice. It was 1 to 1 and onto. It satisfied the definition. But when it doesn't satisfy it, you have to find a counterexample to make it not work. So I'm going to show you an example of that. I'll just record it and say this is a second example to help you with your homework.